Hi folks, almost done. Last section. So 4.7, we are looking at particle motion and with gravity. Then we're going to take a look at speed versus velocity. Then we're going to take a look at average velocity and instantaneous velocity, which are two different things. All right, so we've already done particle motion with gravity. Like we've thrown things off cliffs, we drop things from heights, things like that. That's particle motion with gravity. All right, so this is really just a review for projectiles working under just regular old acceleration. Remember, when we're working in feet, we start off with negative 16 t squared because our acceleration is negative 32 feet per second squared. The v0 is our initial velocity. So like if it's dropped, it's 0. It's always just what it's starting with. If it's thrown at a certain velocity, then that's the initial velocity. And the h0 is our starting height, or our initial height. All right, how high off the ground is it when we throw it, things like that. All right, so those were our equations. So we learned how to do all these things before, at least we went over them. We could find the height at any time t, say t1, would just be h of t1. We just plug in. Time to see when it hits the ground, that's usually we just set it equal to 0 and solve for t. All right, time to return to the starting height, we set it equal to h0, and then we solve for t. Velocity at any time, we take its derivative, h prime of t is equal to the velocity of t. And then if this is, say, t1, then we would say velocity at t1. Right? We plug in the derivative. Velocity when it hits the ground, well, we'd find when it hits the ground, and then we would take that t and plug it into our derivative. And that would be the velocity when it's hitting the ground. When it goes up, that's when the velocity is positive. When it's going down, that's when the velocity is negative. So velocity does have a sign. Positive velocity is going up, negative velocity is going down. Our acceleration is our second derivative of the position, or it's the first derivative. So we want to go v there, huh? The first derivative of the velocity that gets us our acceleration. For both of these, it's constant. For the feet, acceleration is negative 32. For meters, the acceleration is negative 9.8 meters per second squared. All right, so that's all stuff we've gone over before. So that should all be review. I believe it was on either the first derivative test we did, so the second test. All right, the newer stuff, which we talked about in class. Speed does not have a direction. So when you're in your car and you're driving, it's going a certain speed. All right? It's almost always going forward, so the velocity is almost always positive. If you put it in reverse, the velocity is negative, but the speed is still positive. Speed is the absolute value of the velocity, so it's always greater than or equal to 0. Velocity could be positive or negative, speed cannot. All right, so we went over this in class a little bit. We talked about what happens with velocity and acceleration have the same sign. That means it's speeding up. They are working together, so I think they're both going in the same direction, so that means it's going to get faster. If they have different signs, one will be going one way, the other one will be fighting against it, it's going to make it slow down. All right, so different signs, they are going to slow down. Same signs, they are speeding up. Average velocity, it's just the slope. So if we find the slope between the two endpoints, so the average velocity on interval from A to B. So like say if we have, this is say the position equation. I don't know what's happening, it's bouncing up and down, whatever. So this is our position equation. We'll call it x of t. And say here's A and here's B. So B, go straight up there. A, the average velocity here. So we're going to be going up some, then we're going to stop, then we're going to go down some, then we're going to stop and go back up some. It's just going to be the slope of this line. That is the average velocity, that slope. All right, it's kind of a neat thing because this is going up and this is going down and this is going back up. We'll cancel each other out and it'll just end up going down a little bit would be the average velocity. The instantaneous velocity is just the derivative at the value. So if you see the word instantaneous, take the derivative and just plug right in. So instantaneous velocity at B would just be the slope of the tangent line right there at B. How fast is it going? Well, it's going up, it's positive, velocity is positive, speed would always be positive as well for that. All right, motion with gravity. So again, this is review. A ball is shot up with an initial upward velocity, so positive velocity, of 160 feet per second with initial height of 176 feet. Make the height function. Well, our height function, h of t, is negative 16, since we're working with feet, t squared, plus our initial velocity, 160t, plus our initial height, 176. Find the time when the ball returns to the initial height. So it's going to start off by going up, and then it's going to come back to the initial height, and then it's probably going to keep going down for a while afterwards. So to do that, we take our h of t, and we set it equal to 176, our initial height. So negative 16 t squared plus 160 t plus 176. The 176 are going to cancel. So we can factor out a negative 16t. We're going to be left with t minus 10 equals 0. So it looks like t equals 0 and t equals 10. T equals 0 is the starting time when it's there. 10 seconds later, it looks like it's going to hit there. So it looks like t equals 10 seconds is going to be our answer. Find the time when the ball hits the ground. All right, so now we're asking, when does it hit down there? That means the height equals 0. So we want to set h of t equal to 0. So we get negative 16t squared plus 160t plus 176. And we want to know when that equals 0. All right, we could factor that. We could pull out our calculator and graph it. I think we can factor out a negative 16. That might make our lives a little easier. And we'll be left with t squared minus 10t minus 11, I think. Yeah, that's one more 16 there. And this will factor into t minus 11 and t plus 1. And again, we want to know when it equals 0. So we set it equal to 0. We're going to get t equals 11 and t equals negative 1. Well, negative 1 would be going backwards in time. We're not doing backwards in time, so it looks like 11 seconds. I'm going to write SEC so it doesn't look like a 5. So 11 seconds is when it's going to hit the ground. Find the velocity after 4 seconds. Well, velocity is the derivative. All right, so we need to take the derivative. We're going to get negative 32t plus 160. After 4 seconds, we're plugging in 4. So v of 4 is negative 32 times 4 plus 160. Let's see, that's 120, negative 128 plus 160. All right, so we're going to get 2, 5, 32. All right, and that would be in feet per second. It is positive because the 160 was bigger than the 128. Find the speed. All right, so remember, speed is equal to the absolute value of the velocity at 4 seconds. So I guess at 4 seconds it was still on its way up here, so it's still going up like at 4 right there. All right, so the speed would be still 32 feet per second, no difference there. Find the open intervals when the ball is going up. All right, so that means when is the velocity greater than 0? That would be going up. All right, so we take our velocity equation, negative 32t plus 160. And we want to know when does it equal 0. So we're going to get t equals 160 over 32. I don't know what 160 over 32 is off the top of my head, but I do have a calculator handy. 160 divided by 32 is 5. Maybe I did have that one. So we get 5 seconds. So that means, let's see, we'll check what happens before 5 and after 5, and we'll start at 0. We're actually going to stop when we hit the ground here at 11. So we're looking at the sign for v, which is just this function here. So a number less than 5 looks like it's going to be going up, clearly going to be positive there. Number greater than 5, then we're going to come back down. So it looks like that is 5 right there. So it's going to be negative. So that means h of t is going up and then going down. So when is it going down? From 5 to 11. All right? Or if it can go below 0, it'd be from 5 to positive infinity. It would keep going down forever. Maybe it just keeps going and there's no ground. Who knows? Find the average velocity over the interval from 2 to 4. All right, well, that's going to be the position at 4 minus the position at 2 over 4 minus 2. All right, so we need to plug in here, see what happens when we get 4, see what happens at 2, and then divide the whole thing by 2. So negative 16 times 4 squared, which is 16, plus 160 times 4, plus 176 minus, plug in 2, we've got negative 16 times 2 squared is 4, plus 160 times 2, plus 176, and all of that is divided by 2. It's really just calculator work from there. I don't know if I even want to work it out, so it's going to distribute that. The 176's cancel, that's good news. 2 of this 160's cancel, so we get 160 times 2 on top. We've got 16 of these and 4 of those. We're subtracting those, we're adding those, so that's negative 16 times 12. And then that's all divided by 2. So the 2 is going to cancel. So we get negative 16 times 6 plus 160. I'm just trying to, I said 6, root 2. Just trying to get this down as easy as possible. So negative 16 times 6 plus 160 on my calculator gives me 64. All right, and this is velocity, so that means it's going up, and it would be in feet per second. So on average, from time 2 to time 4, so time 2 is probably going to be like here, times 4 is going to be there, we're going up at 64 feet per second. So we're still going up pretty quickly. Find the instantaneous velocity after 8 seconds. Well, that just means h prime of 8, or v of 8. So v, I believe, was right here. So we get negative 32 times 8 plus 160. Let me throw that in the calculator. Negative 32 times 8 plus 160 gives us negative 96. All right, so that's our velocity. So velocity can be negative. If we were asking about the speed, that would be positive 96 feet per second. Right, that's just how fast is it moving. Speed doesn't care about direction. Velocity does care about direction. Technically, it's a vector. Find the velocity of the ball when it hits the ground. Well, we already said it hits the ground in 12 seconds. So we want to know what's h prime, or not 12, 11. 11, which is v of 11, which is negative 32 times 11 plus 160. Negative 32 times 11 plus 160 is negative 192. So it's moving pretty good. All right. Which means the speed here would just be 192 feet per second. I'm just practicing speed. I know it didn't ask for speed, it asked for velocity, so it can be negative, that's fine. What is the acceleration? All right, so that's the second derivative, which is the derivative of the velocity. Derivative of the velocity is just negative 32, and this would be feet per second squared. Okay, a lot of stuff there. All right, so that was mostly review. We added a little bit of speed and average velocity and that sort of stuff. Next time we'll come back and we'll talk about particles moving side to side instead of up and down. So particles can move any way they want to.